Next we have a grouped frequency table. Daisy measured the heights of 20 plants. The table gives some information about the heights, h in centimetres of the plants, and you're given your data there. By using the midpoints of each group, so they give you a hint, work out an estimate for the mean height of a plant. So we know that our formula for the mean, x bar I'm going to call it, is the sum of all of your values divided by the number of values that you have. Now we have a problem here with our group frequency in that we don't know what the sum of our values is. But I do know that one of my values is between 0 and 10, and so if I'm estimating, because I don't know where it is within that, I'm just going to pick the midpoint of my interval. So 5. And there's one of those, so that'd be 1 times 5, so there's a 5. Then between 10 and 20, once again, I don't know where my values are distributed, so I just pick 15 as my value, and I've got 4 of those, so in total that would be 4 times 15, 60. So to work out my overall total, I'm doing my midpoint times my frequency. So that's 5 times 1, plus 15 times 4, and then plus 25 times 7, plus 35 times 2, plus 45 times 3, plus 55 times 3. This question, oh there you go, 55. This question has been nice to you in that all of the intervals are the same, and so finding your midpoint is just effectively adding 5 to your lowest bound. That won't always be the case though, so do be careful with that. So that gives me 610. So all of my values added together, I can estimate to be 610. And there are 20 plants in total, so I'm doing 610 over 20, which gives me my average value of 30.5 centimetres for my mean height of my plant. And I just very quickly want to check in my head, does that make sense? And I do that by looking at my distribution. It's a couple down here, more and more. I peak very much around 20 and 30, and then I get smaller. They're slightly more above 30 than below 30, so I expect to be around about 30, and I am. So there you go, estimating the mean, sorted.